Greetings, everybody. It's good to see you. So when I proposed this, it was going to be a panel, and we were going to have a bunch of distinguished engineers talk to them about software-defined infrastructure. Turned into a lightning talk. Lightning talks are supposed to be very fast, so it's not really feasible to do a panel. So I've pulled some quotes and ideas from these distinguished engineers to talk about software-defined infrastructure and the trends that are happening. So if you think about it, we live in a world today where you and I expect instant service and instant solutions, right? We have very high demands. We saw great examples of this morning in our keynotes. We've got to have mobile access, and we want it to be secure, and we want it to be very reliable, right? We've built our ball and chain with our phones to be access to services everywhere and anywhere that we happen to be, whatever time it is. So our expectations have dramatically changed over the few years. I remember 4 or 5 years ago, our expectations on response times on your browser, right, were milliseconds, whereas today it's microseconds. And so things have dramatically changed, and we're the ones that are driving this change. Our expectations are such that we demand instant services today. So when you think about that from a business perspective, right, think about it from the point of the person trying to provide those services. It basically boils down to 3 points. They've got to provide speed, they've got to provide agility, and they've got to do it in such a way that they're leading their competition. If they don't do that, we as users are so fickle, we just pick up and we move instantly, right? So if we look at the business, and particularly how are they going to accomplish that, the responsibility comes down to the line of business people, it comes down to the CTO, and it comes down to the IT managers. So if you ask yourself the question, okay, what's on their mind? What is it that they're thinking about in order to meet those business needs so that they can satisfy those users? Well, it spans the stack, right? Their infrastructure has got to change. It's got to be much more adaptable, much more agile. The way they're developing applications, their architecture for those applications and services, the deployment models, the whole process about developing those applications and those services is changing. That's what's on their mind. How do they meet that? How do they meet that change so that they can satisfy those users? Well, it turns out what this is culminating in is what we called software-defined infrastructure. It's a new way for delivering those services and those applications. And this is a kind of an eye chart, and we don't have time to go into it in detail. But at the heart of it is OpenStack, right? It's the infrastructure we need to be able to build those services upon it. It includes management, it includes software-defined storage, software-defined networking, things such as containers, so you've got your application development platform and so forth. Putting all those pieces together is what we call a software-defined infrastructure. Now, it's kind of a new paradigm shift or paradigm change to do this model. And I pulled together some of the distinguished engineers to ask them about, okay, so what is it that's most interesting to you about that? And I captured this quote from Allison, and you saw Allison on the stage earlier this morning. And she said this, she said, abstraction is one of the grand trends of computing over the last century. And if you look at this model, the software-defined model, basically what it is it's a bunch of layers of abstraction, okay? So the power we're getting from this abstraction is we're going up the stack and we're abstracting those things away. We're abstracting the data away from the services that are providing it. That's giving us power. That's giving us the power to do more and the power to do bigger and better things. But it's also giving us the ability to do that with less developers and less operators. So less manual intervention, less time that it takes to develop those services, but giving us much more power, much more flexibility at a grander scale. So abstraction is key. But so I pushed on that a little bit, and I asked Armando, who's one of our speakers here at the summit, And he said, you know, if you're not reducing the complexity, so you think abstraction means, oh, things get really complex, and they can. And so he said, you know, but you got to be very careful because you can do all that abstraction and make it so complex that it's not useful. So if you're not reducing the complexity, and if you're not making people more efficient, then it doesn't really matter what you call it, right? So you could call it software-defined whatever, but it doesn't matter because you've got to deliver on that on the promise, right? Delivery on that promise is what is key to the success of this software-defined everything. So we knew we have to deliver on that, and that's why I was really excited about Jonathan's keynote this morning, and something that as a board we've been talking about and working on for the past year, and that is pulling all these pieces together, getting them well integrated so that you can reduce that complexity, right, and pull out that power. And as we talked about this, I asked Cornelius chimed in, he said, you know, we talk about all these fancy technologies and innovations that are happening, but we have to look at it from a holistic view, right? We can talk about containers, we can talk about bare metal, we can, you know, but pulling those all together, you've got to pull them together in such a way that you get that holistic view. And that's the concept behind a software-defined infrastructure. So he says you got to make it possible to not only do the real and fancy stuff, but you've got to do it in a real environment. And that's what really matters, right? So we give all these wild ideas and examples of where and how we can use containers and Kubernetes and whatnot. But the proof of the pudding is when we really put it to real world use. And that's where it really matters. And I thought that was a very astute observation. Now, the other part that comes into this is not just the technology, and as Cornelius pointed out later, when we put it into these real-world environments, it's not just the technology, but it's the processes that are surrounding that business. It's the knowledge and experience of the operators, the developers, that bring together that holistic picture, right? And so if they can't do that, if we can't translate that technology into such a way that they can understand it and exploit it, it doesn't really matter, right? It's fancy technology, but not useful to anybody. Which led me to the next point, which as we were talking with Lars, we were talking about this, saying, well, we've got all these training sessions, we've got the summits, we've got videos out there galore, documentation, yet people still find OpenStack hard and complex. And I said, so what is it we're doing wrong? And Lars said, well, you know, look at it, think about it this way. Think about Linux even 10 years ago, right? Linux was considered very hard, command line interface, who knew how to do bash scripting, Python, all that kind of stuff. And look at it today. It's not that that technology has gone away, it's that the knowledge has expanded and we've become very used to it. So he said, you know, as more and more people walk through the forest, a path develops and it becomes easy to find your way home. What he's really saying is, what we're doing is great, getting all this knowledge out and teaching people and getting them that experience. And what they're doing is paving the way for us. And we're going to have this natural occurrence where a path is developing, enabling others to follow. So we're taking the right steps, we're taking the right actions, developing training and certification, creating all kinds of little videos to train and show people, particularly developers, how to take advantage of these new technologies and pulling them all together. And I thought this was very astute, that it's naturally going to build this path. So 5 years from now, our conversations about the knowledge and experience that we need to learn is going to change, okay? And then the last point here is I asked them, I said, okay, what about the future? What are we looking about the future, particularly around this area of software-defined infrastructure? And again, I think this is an area that Jonathan pointed out very well. And everybody I talk to very much comes in agreement that the future of software-defined infrastructure is open source, right? All the trends that we hear about and are talking about today, be it everything from software development as a platform to software-defined networking and storage and so forth, containers, all the fancy, flashy topics that we're talking about today, all of that innovation is happening in open source. And Jonathan pointed out some of the good examples as to why that innovation is occurring. But we're pretty much gaining agreement that it's going to all be open source based in the future. The second trend is that we will continue to see is optimization. So this is a new model. It's definitely a paradigm shift. And we're going to see optimization throughout all the layers. So we are going to see changes, right? Even in the base stuff that we think has been around for 5 to 7 years, it continues to change. Look at Linux. Linux has been around for 25 years. If anything, if we ever said open source was done, that would probably be it. Yet you look at the contributions that happen with Linux today, it's going up. It's not going down. And we're seeing the same thing with OpenStack and all the other open source technologies. So we continue to learn and we continue to optimize those, and they continue to grow and develop and change to meet those needs, right? Remember, we're in this very dynamic world. This third one that they said very much needs to happen is we're going to get into the area of business insight being driven by data automation, remediation, and self-healing. What he's talking about here is that as we get to these large scales, right, as we get to 100,000 nodes or million nodes and so forth, very much becomes the point that you cannot do that manually, right? You can't hire enough operators to maintain a cloud of that size, right, or an infrastructure of that size. So you have to begin to use business insight to model that, right? So it can't just be pure hardcore policy. It's got to be based off business insight. That's what we as users are expecting, right? Going back to that from the beginning, we're expecting that those services that we're trying to use are smart enough to know that I'm sitting here in Australia today, not sitting back in Utah, right? But I still want those services. So it's got to have that insight to be able to forward those to me. The fourth area is performance through analytics, okay? So not just gathering business insight, but also using analytics to define and ensure that I'm getting that performance no matter where I'm at. And then the last trend is that clouds are going to be distributed across the planet. And we've been talking about this a lot, and actually I'm very excited because, as you noticed in the keynotes today, a lot of those examples that we saw from users are very much distributed. Most of them today are still distributed. Actually, that's not true. They're distributed, what I would say, regionally, but they're growing very much in scale, and clouds are going to, the norm is going to be having clouds distributed across the planet. So I find the future for this whole software-defined infrastructure very exciting. I find the future very optimistic, and I think we're at the heart of it, to be honest, being part of OpenStack. And that's my lightning talk, so thank you.